In these notes today, we're going to be talking about how to write equations of parallel lines. Now, you know that parallel lines are two lines that never intersect at all. They never cross each other. So that means they stay equal distance apart. The math one idea of parallel lines is the fact that you have the same slope. Now, since they're two different lines, they're going to have the same slope, but they're going to have different y-intercepts. Okay, so what you're going to do, what's going to happen is you're going to be given an equation of a line. Look at example 1, the line parallel to y equals 2x plus 3. And you're going to be asked to find the equation of a second line that's going to have the same slope because it's parallel, but have a different y-intercept. Okay, so if I look at example 1, I know right here, my slope for my parallel lines is going to come from right here, and it's going to be the number 2. Now, B, which is your y-intercept, is where the set line is going to cross the y-axis. Well, we're actually given that information right here. We told that it has a y-intercept of 7. So B is going to be 7. Now, I can write that equation really super easy because we know the slope-intercept form of an equation is y equals mx plus b. So our equation here would be 2x plus 7. And what I have done is I have found the equation of the line that is parallel to this one. Notice they have the same slope, but have different y-intercepts. Now, if I wanted to prove that, I could take my calculator and I could go to y equals, let's see that. Let me turn my light on. If I go to y equals and I type in 2x plus 3 and 2x plus 7 and press graph. Okay, let me fix my window. You're going to see parallel lines. There you go. So you see the parallel lines. So that's just to kind of prove that they do make parallel lines if they have the same slope and different y-intercepts. Okay? Now, that's the easiest way when they tell you the slope and the y-intercept. Sometimes they're not going to tell you the y-intercept. What they're going to do is they're going to tell you another point on your line. Okay? If they tell you the equation of the line to start with, and they want the parallel line that passes through another point, what you're going to have to do is go back to that point slope formula. And we did this way back about 3 units back, so we've done this before. It's not new. Okay? What I do know if I'm going to do parallel lines is that my slope right here is going to be negative 3/4. Okay? And I know that my point x and negative 3 is really going to be my x sub 1, y sub 1 in my formula. Okay? So I'm going to write down my formula. Y minus y sub 1 equal to m parentheses x minus x sub 1. Now I'm going to take the 8, the negative 3, negative 3/4 and make sure I put them all in the correct spot. So what I'm going to have is y minus negative 3 equal to negative 3/4 times x minus 8. Now, I'm going to solve this and put this into slope-intercept form. So first thing I'm going to do is take that minus and negative and just turn it into a plus. Over here, I can go ahead and do the distributive property. So I've got negative 3/4 x. Now, be careful right here. Negative times a negative is a positive. Remember our little trick about multiplying fractions and whole numbers? 4 divides into 8 2 times. 2 times 3 is 6. Now I just got one last step to do because I just got to move that 3 over. So I'm going to subtract 3 from both sides. And I'm going to get y is equal to negative 3/4 x plus 3. There's my line that is parallel to my equation up here, but that line is going to pass through the point 8, negative 3. Okay? Now, if I wanted to take time, I could stick that in the calculator and prove it, but I'm not right now. Now, the last two examples go with Hooyvuk's. Now, let's just really super quick do a fast review of Hooyvuk's right here. Hooyvuk's means that horizontal lines equation is y equals a number. Make that an equal sign. A vertical means that you're going to have x equal to a number. Okay, so let's go right here and look. In example 3, what is the equation of the line parallel to x equals 6 and passes through the point 2, 5? Well, now let's just visually think about what's happening here for a second. Got my axis. All right. 1, 2, 3, 4, 5, 6. So the first one says x is equal to 6. Well, we know from Hooyvuk's that x equals anything is going to be a vertical line. Okay? Now, I want to find a line that's parallel to that but goes through the point 2, 5. Well, the point 2, 5 is going to be about right there. Now, if it's parallel, it's also got to be vertical. Now, if that's true, what is its equation? Well, it goes through the x-axis right there at 2, or the x-coordinate of this point is 2, so the equation for that line is just x equals 2. Now, example 4 is the same problem, but it's going to be a horizontal line instead of a vertical. Now, example 4 says, let's find the equation for the line parallel to y equals negative 3 and passes through the point 2, 3. So let me just draw my picture right here so we can kind of see what's happening. Because if you see, picture's worth 1,000 words. If you see the picture, you can kind of make it, oh yeah, that does make sense. So I'm going to go to y equals negative 3. And Hooyvuk's again tells me if it's a y equation, I'm going to have a horizontal line. That's equation y equals negative 3. Now, I want the point that's going to pass through 2, 3 and parallel to that. So if I find 2, 3 up here, 2, 3 right here. Now, if it is parallel to that, that means it's also got to be a horizontal line. And the equation for the horizontal line is the point where it crosses the y-axis, or we can say it's the y-coordinate of the given point right here. So it would be 3. So the equation for this one is y equals 3. Now, if you look at your 4 examples as a big picture, these are the 4 ways they can give this to you. Okay? They can tell you the slope and the y-intercept, and you just go straight to your slope-intercept form. They could tell you a slope and a point that's on the line somewhere other than the y-intercept. That's when you have to do your point-slope formula. If you have vertical or horizontal lines, you got to use the idea of Hooyvuk's. Okay, That's all there is to finding the equation for parallel and perpendicular lines.